This is the review for concept quiz 17. So on part A, we're determining the first 5 terms of the sequence. In number 1, we're given t of 1. So the first term is 500. And we're trying to find the first 5 terms. So I'm trying to find the second, third, fourth, and fifth terms. The recursive definition tells us t of n plus 1 equals 1/5 times t of n. In other words, the next term in the sequence is equal to 1/5 of the current term. So 1/5 of 500 would be 100. Or in other words, you're dividing by 5. So if you divide by 5 again, you get 20. 20 divided by 5 is 4. 4 divided by 5 we can represent as 4/5. The explicit equation is, in terms of n, the equation of the sequence. So we can see that this is a geometric sequence, so we need the initial value, which is 500 times 5, 2500, and the multiplier is 1/5, and that's to the nth power. All right, number 2. We're given a sub 0 is equal to 1, so that's the initial value, and I need to know the first 5 terms. So the recursive definition in this case is saying that the term n is equal to the term before it. A sub n minus 1 refers to the term right before term n, and then plus 5. If you read the recursive definition and you're not sure where to go with it, you could use it as a formula. Same thing on number 1, you could use the equation as a formula. So since I next want to find a sub 1, I'm going to go ahead and plug in a sub 1, n equals 1, so this will be 1 minus 1, and then plus 5. So a sub 1 is equal to a sub 0 plus 5. A sub 1 is equal to a sub 0 we know is equal to 1, so 1 plus 5 gives us 6. First term is 6, but we can see here that all we're doing is we're taking the term before and adding 5. So if we keep doing that, to find the second term, I'm going to take the 6 and add 5 to it, and then keep adding 5 to get the remaining terms. So this is an arithmetic equation, so the explicit equation would give us an initial value of 1 and then plus 5n. Letter B, write an explicit equation and a recursive definition for the following. So the explicit equation, we can see here this is a geometric pattern multiplying by 2, meaning that our multiplier is times 2 to the nth. The initial value would be 5 divided by 2, or 2.5. For our recursive definition, we need to give a term in the sequence. So the first term is equal to 5. And then we need to give a recursive equation. So t of n plus 1, or the next term in the sequence, is equal to the current term multiplied by 2. All right, the last one is multiple choice. Circle all of the following expressions that correspond to the sequence. So looking at each option here, the first one says t of 0 equals -2. So we can tell here by looking at this pattern that we're subtracting 8 each time. So if we add 8, we would get -2, which is the initial value, so that is correct. The second one is giving us an explicit equation with an initial value of -3 and then subtracting 8 each time. Number 1 is not correct. T of 0, if you did -11 plus 8, that's actually -3, not 0, so let's cross that one out. The initial value is actually -3, and then you're subtracting 8 each time, so this is a correct expression. Number 3 is a recursive equation telling us that t of n plus 1, the next term, is equal to 8 plus the current term. Since we knew that we were actually subtracting 8, not adding 8, this would be incorrect. All right, number 4 says that a sub 11 equals negative 90. So to check that, let's just plug in into our known explicit equation. We'll plug in 11 for n, and then check if we get 90. So negative 3 minus 88 is not equal to negative 90, so we'll cross that out. Negative 8 minus 2n, well, in number 2, we got the explicit equation as negative 3 minus 8n. So we can't have a different explicit equation. The initial value is not negative 8, and the adder is not negative 2. All right, number 6 tells us that a sub n is equal to a sub n minus 1 minus 8, or the current term is equal to the previous term minus 8. That is correct since we're subtracting 8 each time to get to the next term.